morning, class. In this beautiful Monday, like usual, we will study together about mathematics with Miss YAFFI. But before we start, let's pray together. Pray, begin. Finish. Hopefully, what we learned today can be useful for us and others in the future. Amen. Anybody absent today? No? Okay, today we will study about geometric transformations. Transformations is mean moving or resize an objects, while geometric is mean anything objects in geometry. But here we only talk about two dimensions. For example, square, rectangular, and so on. All of you already studied about geometric transformations in junior high school. If you have a given point, for example z point, with coordinates x, y, then you translate, rotate, reflect, or delete that point. Then you will have another point, for example z accent point, with coordinates x accent, y accents as the result of your transformations. But in senior high school, you will find the relations between geometric transformations and its matrix. Do you still remember about matrix? Multiplications between two matrices? No? Okay, we recall a little bit about multiplications between two matrices. If we have a multiplication matrix A, B, C, D and matrix M, N, this multiplication matrix is equal with this matrix AM plus BN, like this one, CM plus DN, this one. So this multiplication matrix is equals with this matrix. Before we find the relations between geometric transformations and its matrix, I have an interesting video about geometric transformations in real life. So please pay attention to the screen and enjoy! Some of geometric transformations in real life, but actually there are still many applications of geometric transformations. It's very interesting, isn't it? So are you ready to study geometric transformations? Okay, that's good. Today we will study in groups. Each group will contain 3 until 4 students. Groups that contain 4 students will discuss about reflection respect to x-axis, reflection respect to y-axis, and reflection respect to point O with coordinates 0, 0. And groups that contains 3 students will discuss about reflection respect to y equals to x lines and reflection respect to y equals to minus x line. Your task is find the relations between reflections and its matrix. Each group will have different worksheets depends on the reflection that you got. To guide you, find the relations between reflections and its matrix. You have 20 minutes to discuss with your groups about the solution for the given problems in the worksheets. If any questions, you can raise your hand and ask me. Then, after 20 minutes, one member of each group please come forward to explain and demonstrate your solutions using Geogebra. Later on, I will demonstrate how to find reflections using Geogebra. But, any questions so far? No? Okay, now please attention to the screen. I will demonstrate how to find reflections using Geogebra. Okay, actually you won't use any software that help you find the reflection of an object. But here I just demonstrate one software that help you find the reflection of an object. This software is Geogebra. This software is easy to use and easy to download. This is the application Geogebra for 5th editions. Okay, If we have a given triangle ABC with A 1.1, B 2.3, and C minus 2.4, then we refract the triangle respect to x-axis, y-axis, point O with coordinate 0.0, and y equals x line and y equals minus x lines. First thing that we have to do is we plot each point in triangle ABC, A, B, and C. Okay, A with coordinates 1.1. We choose here point and click coordinates 1.1. Then we have A. B 2.3. 2.3. Then we have B. Then C is minus 2.4. Minus 2.4. Then we have C. After have each point in triangle ABC, now we can make triangle ABC by click this polygon and click A, B, C, and back to A. Then we have triangle ABC. Now we want refract the triangle ABC respect to x-axis. We choose here refract about line, then click the triangle ABC and x-axis. Then we have triangle A-axis, B-axis, and C-axis. With coordinates A-axis is 1 point minus 1, B-axis is 2 minus 3, and C-axis is minus 2 point minus 4. Okay. Now we want refract the triangle ABC respect to y-axis. We unhide all the item of A-axis, B-axis, and C-axis. Okay. Now we reflect the triangle ABC respect to y-axis. We choose here reflect about line, then click triangle ABC and y-axis. Then we have triangle A1 axis, B1 axis, and C1 axis. With A1's axis is minus 1.1, B1's axis minus 1.3, and C1's axis 2.4. This triangle is the reflection of triangle ABC respect to y-axis. Now we hide all the item A1 axis, B1's axis, and C1's axis. Okay. Now we refract the triangle ABC respect to point O with coordinate 0.0. First, we plot the coordinates of O in coordinate plane. We choose here point and click 0.0. Then we have T with coordinate 0.0. We rename it to point O. We choose here rename, then type O, capital O. Okay. After have triangle ABC and point O, we choose here reflect about point. Then we choose triangle ABC and point O. Then we have triangle A2 axis, B2 axis, and C2 axis. Okay. Now we unhide the all item of triangle A2 axis, B2 axis, and C2 axis. Okay, hold a second. Okay, we unshow the objects. Okay,
and unhide all the point of A2 axis, B2 axis, and C2 axis, and also point O. Then we reflect the triangle ABC respect to y equals x lines. First, we make y equals x lines first by typing in input y equals x. Then we have the lines. After have the lines and the triangle ABC, we choose reflect about line and click triangle ABC and y equals x lines. Then we have triangle A 3 accents, B 3 accents, and C 3 accents with coordinates of A 3 accents is 1.1, B 3 accents 3.2, and C 3 accents is 4.-2. Okay, now we unhide all the item of A 3 accents, B 3 accents, and C 3 accents by unshow the objects. Okay, and hide all the item A 3 accents, B 3 accents, and C 3 accents, and also the lines. Okay, now we reflect the triangle ABC respect to y equals minus x lines. We input the line first, y equals minus x. Then we have the lines and triangle ABC. Now we choose here reflect about line and click triangle ABC and y equals minus x lines. Then we have A4 accents, B4 accents, and C4 accents with coordinates A4 accents is minus 1.-1, B4 accents is minus 3.-2, and C4 accents is minus 4.2.
Okay, that's the demonstration. Now, discuss with your own groups and I'll give you 20 minutes. Time's up! Now, time to you to present your discussion results. One member of each group, please come forward to explain and demonstrate what your discussion results. Let's start with the first groups.
Hello, my name is Tiandra. I'm from the first group. I want to present my discussion result about the relations between reflection respect to x-axis, y-axis, and the point O with coordinates 0.0 and its matrix. My member of group is Tiandra, it's me, Rafli, Rebecca, and Adifa. We are from 11 Science 1. Okay, let's go to the first question. Using Geogebra, find reflection of the following point respect to x-axis. Given point A, B, C, and D, with A is 1.3, B is minus 2.-5, C is minus 3.4, and D is 6.-2. I already plot each point in Geogebra. Now we will find the reflection of each point respect to x-axis. we choose reflect about line, click point A and x-axis, P and x-axis, C and x-axis, and also D with x-axis. Then we have A accents, B accents, C accents, and D accents. With A accents is 1 point minus 3, B accent minus 2.5, C accent is minus 3 point minus 4, and D accents is 6.2. These reflections is equal with my group's answer that written in the red font. Okay, if A is, now we look at the pattern. If A is 1.3, then A accents is 1 point minus 3, B minus 2 point minus 5, then B accent is minus 2.5, C is minus 3.4, then C accent is minus 3 point minus 4, D is 6 point minus 2, then D accent is 6.2. So if we have given point, for example Z with coordinates x, y, then we reflect to x-axis, then z-axis is equals or will have coordinates x, minus y. If a, b, c, d is a real number and assume that x-axis and y-axis is reflection of x and y respect to x-axis, we can write like this matrix: multiplication of a, b, c, d and matrix x, y. This matrix, multiplication of matrix, is equal with ax plus by and cx plus dy. Then we substitute x, minus y to x-axis and y-axis. We have this matrix. Then we have x equals to ax plus by minus y equals to cx plus dy. From the first term, we have a equals to 1 and b equals to 0. From the second term, we have c equals to 0 and d equals to minus 1. Then we have the reflection of matrix reflection of x-axis is abcd that 1, 0, 0, minus 1. Then we generalize the reflection of a with coordinates x plus x, y respect to x-axis is a accent coordinates x-axis, y-axis with multiplication of 1, 0, 0, minus 1 and x, y. And the number 2, we have using Geogebra find the reflection of the following point respect to y-axis. We have same given point like the previous number a, b, c, and d. Then we find the reflection respect to y-axis. We hide a accent, b accent, c accent, and d accent first. Then we reflect each point respect to y-axis. Okay. Then we have the reflection is A1 accents, C1 accents, D1 accents, and B1 accents with coordinates A1 accents is minus 1.3, B1 accents is 2 point minus 5, C1 accents is 3.4, and D1 accent is minus 6 point minus 2. That's equals with my group's answer written by red font like this. And now we look at the pattern. If we have A is 1.3, then A accents is minus 1.3, B minus 2 point minus 5, then B accent is 2 point minus 5, C is minus 3.4, then C accent is 3.4, D is 6 point minus 2, then D accent is minus 6 point minus 2. So if we have a given point, for example Z with coordinates x, y, then we reflect respect to y-axis, then we have z accent with coordinates minus x, y. And if ABCD is a real number and assume that x-axis and y-axis is reflection of x and y respect to y-axis, we can write x-axis and y-axis as the result of multiplication this matrix. This matrix is equal with ax plus by, cx and dy plus dy. Then we substitute z-axis into x-axis and y-axis. We have this matrix. Then this matrix can be formed into two different forms. For the first form is minus x equals to ax plus by. C is equals to cx plus dy. From the first term we have a is minus 1, b is 0, c is 0 and d is 1 from the second term. So the matrix reflection of y-axis is ABCD that equals to minus 1, 0, 0, 1. Then we generalize the reflection of A with coordinates x, y respect to y-axis is a-axis with coordinates x-axis point y-axis as the result of multiplication of matrix minus 1, 0, 0, 1 times matrix xy. And the last number is using Geogebra, find the reflection of the following point respect to O with coordinates 0, 0. The given point is equal with the previous point A, B, C, and D. First, we hide all of A1 axis, B1 axis, C1 axis, and D1 axis. Okay, then we have A, B, C, and D. Now we plot O with coordinates 0, 0. Then we rename point A with O, capital O. Okay. After have A, B, C, D and point O, then we will reflect each point A, B, C, and D respect to O. We choose reflect about point, click A and O, click C and O, B and O, and D and O. Then we have A2 axis, B2 axis, C2 axis, and D2 axis. A2 axis is minus 1 point minus 3, B2 axis is 2.5, C2 axis is 3 point minus 4, and D2 axis is minus 6.2. This reflections is also equal with my group's answer. A axis, B axis, C axis, and D axis, written by red font. Now we look at the pattern. If we have A with coordinates 1.3, we have A axis with minus 3 point minus 1 point minus 3, B minus 2 point minus 5, then B axis is 2.5, C minus 3.4, then C axis is 3 point minus 4, D is 6 point minus 2, then D axis is minus 6.2. Then if we have a given point, for example Z point with coordinates x, y, we reflect respect to O with coordinates 0, 0. Then we have Z axis with coordinates minus x, point minus y. If ABCD is a real number and assume that x-axis and y-axis is reflection of x and y respect to O with coordinates point 0, 0, we can write into this matrix ABCD times x, y. This multiplication matrix is equals to ax plus by, cx plus dy. Then we can substitute z-axis, the coordinates of z-axis, to this matrix. Then we have minus x minus y equals to ax plus by and cx plus dy. We can write into two different form. For the first form, we have minus x equals to ax plus by, and second form is minus y equals to cx plus dy. From the first term, we have a is minus 1, b is 0, c is 0, and d is minus 1. So the matrix reflection of O with coordinate is 0, 0 is ABCD, that's equals to minus 1, 0, 0, minus 1. Then we generalize the reflection of A with point x, y respect to O with coordinates 0, 0 is a axis with coordinates x axis and y axis. With x axis and y axis is multiplication of minus 1, 0, 0, minus 1 and matrix x, y. I think that's all from my discussion groups. Thank you.
Okay, give applause to Diandra. Is there any questions about the first group explanations? Especially from the second group, because the second groups have different topic with the first groups. No questions?
No, ma'am.
Okay, we can continue to the second group.
Hello, my name is TIARA. I'm from second groups, and I want to present my discussion result about the relations between reflections respect to y equals to x and y equals to minus x lines in each matrix. My member of group is TIARA, it's me, Melinda, and Yusuf. We are from 11 Science 1. Okay, let's go to the first questions. Using Geogebra, find reflection of following point respect to line y equals to x. Given point A, B, C, and D, with A is 1.3, B is minus 2.5, C is minus 3.4, and D is 6.2. I already plot each point in Geogebra. Now, we will find the reflection of each point. But first, we have to plot or graph the function of y equals to x. And we have this line. This line is y equals to x. After have y equals to x lines and each point, then we will reflect each point respect to y equals to x line by click reflect about line and click each point and y equals to x line. A and this line, B and this line, C, and also D. Then we have A axis, B axis, C axis, and D axis. With coordinates of A axis is 3.1, B axis is minus 5.2, C axis is 4.3, D axis is minus 2.6. These reflections is equals with my group's results written by red font. Now we look at the pattern. If we have A 1.3, then A axis 3.1, B minus 2.5, then B axis is minus 5.2, C minus 3.4, then C axis is 4.3, D is 6.2, then D axis is minus 2.6. So if we have a given point with coordinates x, y, then we reflect that point respect to y equals to x lines. Then we have z axis point with coordinates y equals to x. If ABCD is a real number and assume that x axis and y axis is reflection of x and y respect to line y equals to x, then we can write x axis, y axis is equals to multiplication matrix of ABCD and matrix x, y. This multiplication matrix is equals to ax plus by and cx plus dy. From this matrix, we can substitute y equal y point x to x axis and y axis, then we have this matrix. And we can form two different forms from this matrix. for the first form is y equals to ax plus by and x equals to cx plus dy for the second form. For the first form, we have a equals to 0, b equals to 1, and c equals to 1, and d equals to 0 for the second term. So the matrix reflection of line y equals to x is ABCD. It's equal to 0, 1, 1, 0. Then we generalize the reflection of A with coordinates x, y respect to line y equals to x is A accent with coordinates x accent, y accent is the multiplication of matrix 0, 1, 1, 0 and matrix x, y. Then the second questions is using GeoGebra, find reflection of the following point respect to line y equals to minus x. We have same given point like the previous questions A, B, C, and D, but now we reflect each point respect to y equals to minus x. We hide first A accents, B accents, C accents, and D accents, and also we hide the y equals to x lines. Then we have A, B, C, and D. Now we plot y equals to minus x lines. Then we have these lines. Each point will reflects to this line. So we choose reflect about line, click each point and these lines, A and these lines, B, D, and C. Then we have A1 accents, B1's accents, C1 accents, and D1's accents. With A1 accents is minus 3 point minus 1, B1 accents is 5.2, C1 accents is minus 4.3, D1 accents is 2 point minus 6. These reflections is also equals with my discussions groups or my discussion results. A accents, B accents, C accents, and D accents. Now we look at the pattern. If A is 1.3, then A accents is minus 3 point minus 1, B minus 2 point minus 5, then B accents is 5.2, C minus 3.4, then C accents is minus 4.3, D 6 point minus 2, then D accents is 2 point minus 6. So if we have a point, for example Z point with coordinate x, y, then we reflect this point respect to y equals to minus x lines, then we will have Z accents with coordinates minus y, minus x. So if ABCD is a real number and assume that x accent and y accent is reflection of x and y respect to line y equals to minus x, we can write this term, this multiplication matrix x accent y accent equals to ABCD times matrix xy. This multiplication matrix is equals to ax plus by, cx plus dy. Then we substitute z accents to x accents and y accents. We have minus y and minus x equals to ax plus by and cx plus dy. Then we have, for the first term is minus y equals ax plus by. Then we have a is 0 and b is minus 1. And for the second term, we have minus x equals to cx plus dy equals to, then we have c minus 1, d is 0. So the matrix reflection of line y equals to minus x is ABCD with a is 0, b minus 1, c minus 1, and d is 0. Then we generalize the reflection of a with coordinate x, y respect to line y equals to minus x is a accents with x accents, y accents. that equals to multiplication of matrix 0, minus 1, minus 1, 0, and matrix xy. That's all for my groups, my discussion groups. Thank you.
Okay, please give applause to Tiara. Is there any questions about the second group explanations? Especially from the first group because have different topic with the second groups. No questions?
No, ma'am.
How about our lesson today? Is there any questions?
No, ma'am.
No? Are you sure?
Yes, ma'am.
Okay, if there is no questions, then we will have a short test using Schoology. Please check your account. There are 10 short questions. Do it independently and I'll give you 15 minutes to finish your test. Good luck! Have all of you done the quiz?
Yes, ma'am.
Okay, today we already studied about geometric transformation, especially about the relations between reflections and each matrix. If we have a point, for example z point, with coordinates x, y, then we reflect that point respect to x-axis, then we will have the coordinates of z-axis point is x-axis, y-axis as the result of multiplication matrix 1, 0, 0, minus 1, and xy. And if we reflect z point respect to y-axis, then we will have the coordinates of z-axis is multiplication of matrix minus 1, 0, 0, 1 times matrix xy. If we reflect z point respect to point O with coordinates is 0, 0, then we will have the coordinates of z-axis is the multiplications of matrix minus 1, 0, 0, minus 1 times matrix xy. And if we reflect z point respect to y equals x lines, then we will have z-axis is the multiplications of matrix 0, 1, 1, 0, and matrix xy. And the last, if we reflect z point respect to y equals to minus x lines, then we will have the coordinates of z-axis point is multiplication of matrix 0, minus 1, minus 1, 0 times 2 matrix xy. Is there any questions about our lesson today?
No, ma'am.
No? Okay, I think that's all for today. Thank you for your attentions and participations. Next week, we will study about the relations between rotations and its matrix. So don't forget to study before the next meetings. See you next week. Wassalamualaikum warahmatullahi wabarakatuh.